Hi, my name is Emil Marino, and this video is for my statistics class with Mr. Scogin, and it is the midterm video. Before I get started, I'll show my ID and my face to prove that it's me. And so, we have two problems to do, the first of which I'll explain. So, since the first problem deals with mean, median, and mode, I'll go through each of them and explain what they are. So what is the mean? It sounds kind of scary, right? But it's actually just the average of the data set. It's where most of the numbers will lie or fall around. So that will be your mean. Next is the median. So the median is where the midpoint of all the integers will lie. And it won't always be a number that's in the data set. So maybe the data set we'll get won't even have a median that's on it. So we'll see. And the last but not least is the mode. So the mode will be the number that appears most often in the data set. And another interesting fact about the mode is that there can actually be two. And that is known as a bimodal data set. So let's get started with our data set. So I've written down all the numbers that we've been given, and this is our data set. So let's start off by finding the mean. Now, as I explained, to find the mean, it is the average number. So we're going to start by adding all of these numbers up together. So 10 plus 12 plus 11, 13, 9, 7, 27, and 30. Now let's add all of these numbers up and see what we get. So when we add all of these numbers up, we end up with 119. And so what do we do with that number now? Well, now we must count however many numbers there are in the data set. So let's see. There are 2, 4, 6, 8, 10, 12, 14, 16. So we must now do 119 divided by 16. And that should give us, on the calculator, 119 divided by 16 will give us 7.43. But then we can also round that up and just have it be as 7.4. And that is how you find the mean. So now we are on to finding the median. And the first step to finding the median is putting all the numbers in order from least to greatest. That always used to trip me up in the beginning, but now I've got it, so let's do that together. So we have 1, 2 2s. How many 3s have we got? 2 3s. Where's it 3? 5 and 6. I'll pause here. Alright, so I had to recheck my work. But let's start again. So let's start by putting them in order from least to greatest. So I've written all the numbers from least to greatest. And now the next step is something that I learned in elementary school. And it's always worked with me. So I like to call this the cross-out method. So you take one from the right side, cross it off. Take one from the left, cross it off. 2, 2, 3, 3, and so on until you have 1 left in the middle. And let's see, that number will be 6. So 6 is going to be our median. Now that was actually quite simple, but it won't always be that simple. Sometimes you get 2 numbers in the middle. But for that case, you would add them together and then just divide by 2. Thankfully, this was an easy case though. So now we're going to move on to the mode. Now the mode is the number that shows up the most in the data set. And like I said earlier, you can have more than one mode. So let's see if that will be the case. We've got how many 8s? Just 1 8. How many 6s have we got? Wow, we have 3 6s, okay. So let's take note of that. We've got 3 10s. Boy, that's a lot. How many 3s have we got? 1, 2, just 2 3s. 11, just 1. 17, just 1, 2. Just 2. 1, 1. 3, 10. 3, 6. Okay, so as we see here, there are 3 6s and 3 10s, and that's completely fine. So this is called a bimodal data set. And there's nothing wrong with it. You can totally have 2 modes. So in conclusion, the mean we got was 7.4 when we rounded. The median was 6. And the mode is 6 and 10. And with question number 1 completely solved, we'll now move on to the second part of the midterm video. So our next topic is binomial distributions. And I'll give a brief overview before we actually get into the problem. So what are binomial distributions? It sounds like a big, scary topic, but we use it more than you think. Like, for example, flipping a coin in a coin toss or shooting a goal in a soccer match. Well, you might ask, like, what do these 2 have in common? They're very different, I know. But they both have a set number of trials, and they each have 2 paths. One of success and one of failure, which you get to define. For example, if you pick heads, if you want to land on the heads, that is your definition of a success. So you can either land on heads, your success, or tails, your failure. And in soccer, if you want to shoot a goal, that is your success. You can either make the goal or you can completely miss, and that is your set failure point. But you can't do both at the same time because this is known as mutually exclusive events. You can't land on heads and tails at once, and you can't goal and miss at the same time. It's just not possible. So yes, those are some examples of binomial distributions, and let's jump into the problem now. Here I've outlined of what we need to solve the problem. So here are all of our definitions, and I'll read them out loud. So where n equals the number of trials, p is your probability of success or shooting the goal in soccer, and q is the probability of failure in one trial or missing the goal in soccer. And x will be your random variables, which you will see later in the problem as we solve it. And this is the formula we use to solve these kinds of binomial distributions, where C represents combinations, which we'll put in the calculator to solve. Now with this in mind, we can start the problem. The problem reads, 34% of U.S. adults have very little confidence in newspapers. You randomly select 8 U.S. adults. Find the probability that the number of U.S. adults who have very little confidence in newspaper is, And here are our stipulations. I don't know if you can see, but A, exactly 6, and B, less than 5. So let's start by defining our variables first. N will equal 8, since you chose 8 people. P is 0.34. Q, or failure rate, will be 1 minus P. So you will do 1 minus 0.34. And that will get you 0.66 for your Q. And now you take these and you just plug them into this equation. So let's see what that gets us. P of 6, since we're doing A exactly 6, equals 8C6 times 0.34, because that is our P, and we're going by this equation up top, to the 6th power, because that we have to do X right there, times 0.66 to the 2nd power, because 8 minus 2, I'm sorry, 8 minus 6 equals 2, our N and our X. And this, when we put it into the calculator, will come out to be, give me a moment, it will give us 0.018884, and it just goes on and on and on. So we can just say 0.0188, and to round that, we can just leave it at 0.2 to make things a lot simpler. So how would you interpret that? In English, you would say 2%, or 6 out of those 8 people you chose have very little confidence in having newspapers as the #1 main source. Actually, I'm going to rewrite this because I'm not sure about the 8 out of those 8 people were right, but definitely you could say 2% of those chosen in this sample have very little confidence in newspapers. So now we can go on to our second stipulation, which is P is less than 5 people. So all of our variables will be the same, so we don't have to erase any of that. But this one's going to look a bit different. And this is when that variable, I'll show you. This is when the number of variables that look like this are going to come into play. So since P is less than 5, P is going to equal every number below 5, going all the way down to 0. So we're going to have 4, 3, 2, and 1, and of course 0. So it's going to look like this. This is what you're going to start off with, and then you're just going to plug each number into the equation. You're going to replace your X value with these numbers. So NCX, your N is still 8, and your X will be whatever number you have going this way. So NCX, this is going to be your X. So 8C4. And you'll just continue to do the same equation over and over, and you'll get your different answers. Now, once you get your different answers, you are going to add all of them up. Let me do that first. So it's a lot of repetition, but here's all the equations worked out, and I got my final answers. I decided to add them all, and I got 0.905, which is 3 decimal points. So I rounded it to 2, and it can be up to 91%. So in English, we can interpret that as there being a 91% probability of there being less than 5 people who have very little faith in the newspapers. And that is how you do the binomial distributions. This has been my midterm video. And thank you so much. It was really fun.